Hey, example number 2 for 7-6 coming at you live from mi casa. Hola, casita. Ooh. I'm so thrilled to be doing this on February break. It's fine. It's fine. It's fine. I love you guys. I love you guys so much. All right, example number 2. The enrollment at a local community college is decreasing. Oh, hey, keyword decreasing. I bet that means when we use our handy dandy formula, we're going to be using the minus sign instead. By, as it says, 5% each year. So what percent remains after 1 year? Okay, well, just like when we started, that initial amount, that starting value is that 100%. 100% is the starting percent. 100% is that starting. And what's happening? We said it was decreasing, so we're going to subtract by 5% each year. 100 minus 5, I don't know why I set that up like a elementary student, but I did. So what percent will be left? 95. Not to say that there's going to be 95 students left all the time. Remember, that's not the same thing, but there will be 95% of the population left each year if it continues to decrease by 5% each year. So part B, if the student body population is 2,300 and continues decreasing at that same rate, and again, even though it's saying decreasing at the same rate, that again is still not a linear situation. A percentage is not the same as increasing by the same amount each time or decreasing like we saw last time. And we'll see. It's not linear. And the percentages cannot be linear. So anyhow, what will the population be 4 years from now? So I'm going to go back and use that original percent increase and decrease formula we came up with. The y equals the initial value, parentheses 1 plus or minus percentage divided by 100 raised to the t time. So here we go. My initial value is that 2,300. 1 plus or minus. I'm using the minus again because it's decreasing. We already talked about that. What percent is it decreasing by? The 5% that we talked about out of the 100. And since it's asking me 4 years from now, I will be raising that to the 4. Fourth power, I mean, yeah. So I'm just going to, again, simplify this a little bit so we can take a look at what happens inside those parentheses because it is worth talking about. 5 divided by 100 is 5 hundredths, and 1 minus 5 hundredths leaves me left with 0.95 or 95 hundredths. And again, that 95 hundredths isn't random. That matches, that's the percent that's left over. So that's really worth saying something. That represents the 95% left. Because, again, the 5% is what's being taken off. So we can go ahead and math that. 2,300 parentheses 0.95 caret. I also like simplifying a little bit like that too because it's easier. Okay, so we are talking about, again, student body population, and I had to pause for 2 seconds and go back and reread that to make sure that I knew that, which means I'm going to want to round to the nearest whole number. So 1873.36, 1873.36. Also double checking in my brain that it makes sense that I'm ending up with a smaller number because the population is decreasing here. Rounding to the nearest whole number, because we're talking about students, would give me 1,873 students. Boom. And last but not least, what is the total percent decrease from the starting population to the population after 4 years? Okay, so this is important because we struggle with this a lot. You see this question and you're not really sure what formula to use, and never fear, I'm here to help you with that. When it asks about a percent decrease or increase, this is telling you to use the percent change formula. which, if you need a reminder, you can find that in 7-5, or I will, tell you now, percent change PC is equal to that new minus the original divided by that original. That gives you the decimal, so you need to multiply that by 100 in order to... I'm confuzzled. Why is that not... Hamana, children. Hamana. I don't like the way that's being that way. Okay. Anywho, times the 100 to convert it into the percentage, because that gives you the decimal. All right. We'll deal with that at another time. Okay, so filling pieces in. Percent change is going to be equal to, so the new number, which is the new number, the most recent number that we're talking about. That would be the one after 4 years, because that's most recent. So this new number is that 1873 compared to the original, or my initial value, was that 2300. Divide by the original times that 100. And once I get to that, I can just go ahead and plug that right into the calculator, or do the math right in the calculator at least. 1873 minus 2300. Making sense that I'm getting a negative number because we're talking about a percent decrease here. So none of this is surprising to me. This is all making sense. Divide by that original of 2300 times by 100. You want to make sure you're doing all the multiplication and division first before you're rounding. Rounding needs to be the very last thing that you do. So leaving me with a percent change of 18.565. It did not tell me what to round to, so I'm going to round to the nearest hundredth because that's what I do. So it was an 18.57% decrease. Leaving off that negative because I'm using the word decrease instead. So there you go. Again, proving to you that it's not the same percentage. You might think that after 4 years, if it's decreasing by 5% each year, 4 times 5 would just be 20. But you can see it's not that exact amount. That's why it's not considered linear, and it is an exponential relationship. So, boom!